NCERT exercise. Okay, this is 6.4. You see question number 6.4. Main exercise is starting from here only. Before that, question number 1, 2, 3, they are just tick type questions or true false type questions. We won't be covering. We will be discussing mainly the numerical problems, right? So 6.4, let's read it out. Question number 6.4. The potential energy function for a particle executing linear simple harmonic motion is given by V is equal to half kx square, where k is force constant of the oscillator. For k equal to 0.5 Newton per meter, the graph of V versus x is shown. Show that a particle of total energy 1 joule moving under this potential must turn back when it reaches x equal to plus minus 2 meter. So what is V here? That is potential energy. V is potential energy and it is also equal to 1 joule. They have given the value. Simple harmonic motion means it is an oscillatory motion, right? And when we put the value of k, we will get some value of x. That would be our answer, that particle moving with this potential must turn back when it reaches x equal to plus minus 2 meters. So let us check whether we get x equal to plus minus 2 meter or not, using the expression for V, potential energy, that they have given. So exercise, according to question, energy is half kx square and also energy is given 1 joule, k is given 0.05 Newton per meter. You know the value of force constant and unit Newton per meter, F is equal to kx, using that. So let us put in both the values and find x. V is 1 half, k is 0.05, okay, 5 by 100 x square. So find x from here, you will get plus minus 2. Okay, x from here will be plus minus 2. So your answer is verified. Let me check what was k. K was 0.5 or 0.05. So I'm going to share exercise once again. 0.5. It is 0.5. K is 0.5. So x square is 4. X is under root 4. That is plus minus 2 meter. So here comes the answer. X is plus minus 2 meter. Have a look at the solution once. If there is any doubt, you can ask. So this is question number 6.4 of the exercise. All right. Fine. So I'm going to share next question now. Let us see next page. Because 6.5 is also of that type, conceptual type. So you can do that. Wait. Okay, let us come to question number 9, 6.9. A body is initially at rest. That means U is 0. It undergoes one-dimensional motion with constant acceleration. So mind it, acceleration is constant. So question number 6.9. Acceleration is constant. It starts from rest, means U is 0, right? The power delivered to it at time t is proportional to what? We are to find power is proportional to what power of time? What is the dependence of power on time? Let us solve this. So acceleration is constant and u is 0. Power we have to find. So power is force into velocity. F is equal to ma, and acceleration you can write velocity over time, or let us put velocity as acceleration into time, because in terms of acceleration we have to express acceleration is given constant. Okay, so since acceleration is constant, mass is also constant, power is directly proportional to time. So it is proportional to first power of time. This is our answer. If acceleration is constant, mass is already a constant, power will be directly proportional to time. So P is proportional to T here. Okay, let us see next question now and have a look at the question also. So our second part is correct. Answer to question number 6.9 will be second part, that is time t. Now see question number 10. A body is moving unidirectionally under the influence of a source of constant power. Its displacement in time t is proportional to what? Now power has been given constant and displacement we are to find. So let us see what we can do in this question. So this is question number 10. Okay, question number 10. Power is given constant. Okay, and we have to see the dependence of displacement on time in this case. Again, we can write power as force into velocity, which is a constant. Force is F is equal to ma again. And again we can put velocity is acceleration into time. So ma square t is a constant. Mass is already a constant, but here acceleration is not a constant. So we will say that acceleration into t is a constant, or acceleration is inversely proportional to under root of time. Is this step clear to you? Acceleration is inversely proportional to under root of time, because a square t is constant. So a is constant over t, a square is constant over t, or a is constant over under root of t. So a is proportional to 1 over under root of t, we can say that. Right, so let us preserve this information. We are to find displacement. So what will be displacement s? We can write ut plus half at square. U is 0 again. So s is half at square. Now half is a constant and acceleration is proportional to 1 over under root t. So s is proportional to under root 1 over t into t square. If we see only time, time is a variable, right? So we have taken half to be a constant, and acceleration proportionality also we have substituted. So displacement must also be proportional to this, that means, right? So let us solve this. S is proportional to t square minus 1 by 2. The power of under root t means t raised to power 1 by 2. So when it goes in the numerator, it is minus 1 by 2. After taking LCM, 4 minus 1, this is 3 by 2. So displacement is directly proportional to t raised to power 3 by 2. This is the kind of dependence. Please see, it's a very good, interesting question. See how we have solved. So this part will be correct. S is proportional to t raised to power 3 by 2. This is the kind of dependence of displacement on time. Let us see the question once again. So which part is correct? Third part is correct. Third part is t raised to power 3 by 2. This part is correct, that means. All right. Now question number 11. A body constrained to move along z-axis of a coordinate system is subject to a constant force F given by, let me note this force down, F is equal to (6.11). F is equal to minus I cap plus 2j cap plus 3k cap Newton. Unit is Newton. Where I, J, K are unit vectors along x, y and z axis of the system respectively. what is the work done by this force in moving the body a distance of 4 meter along z-axis? So distance is 4 meter along z-axis, and we know that the unit vector along z-axis is k cap. So better we can write displacement vector as 4k cap meter. So we also express displacement vector in vector form. So this must be 4k cap Newton. We are to find the work done. You know, work is dot product of force and displacement. Put in the values and you know how to find the dot product. Displacement is 4k cap, force is minus I cap plus 2j cap plus 3k cap. Okay, let us take the dot product, multiply I component with I component. There is no I component here, so it is 0. Again, no j component, 0, plus multiply their k components together, 3 into 4, that is 12. And what is the unit of work? Joule. So our answer is 12 joule, and we know that it's a scalar quantity. Dot product of two vectors is always a scalar. So we get work is equal to 12 joule. Got it? Is that clear? All right. So question number 11 is clear to you. Any doubt you can tell me? Okay. Let us see next question after 6.11. We have question number 12. An electron and a proton are detected in a cosmic ray experiment. The first with kinetic energy 10 kilo electron volt and the second with 100 kilo electron volt. Which is faster, the electron or the proton? Okay, first thing we have to find this out. Which one will be moving faster? Obviously electron, because its mass is less, it is lighter. Obtain the ratio of their speeds, but we can't predict it verbally. So we have to find the ratio of the speeds mathematically to predict this. Mass of electron is given, mass of proton is given, 1 electron volts value is also given to you in joule. Okay, so I don't think so we will need the value of electron volt, because both the units are in kilo electron volt, so they will get cancelled when we will be taking the ratio. So let us find the ratio of energy of electron to the energy of proton. You know, very simple formula of kinetic energy will be using half mv square, right? So let us find kinetic energy of electron to kinetic energy of proton. 10 upon 100, that is given. 12th question. Kinetic energy of electron, that is given 10 keV, kilo electron volt. Kinetic energy of proton, they have given 100 kilo electron volt. So let's find the ratio. Half mass of electron, velocity of electron square, half mass of proton, velocity of proton square. This gets cancelled. Let us put in the values. We have to find the ratio of their speeds. Kinetic energy of electron 10 kilo electron volt, proton 100 kilo electron volt. Units are same, so we need not do the conversion here. Right now, as such, we will put the values. Mass of electron 9.1 into 10 raised to power minus 31, and mass of proton 1.6 into 10 raised to power minus 27 kilogram. VE by VP square. VE by VP square. Right. So VE by VP can be written as, so solve this. All of you solve this. 1.6 into 10 raised to power minus 27, 9.1 into 10 raised to power minus 30. When we multiply it with 10, the power becomes minus 30. Okay, and since it was square, it will be under root of this. It will be under root of this, and when you will solve it, you will see that this ratio is greater than 1. This ratio will be greater than 1 because 10 raised to power minus 27 plus 30. Okay, 1000 will be there in the numerator. So this ratio is coming out greater than 1. That means velocity of electron is this much factor times the velocity of proton. So electron is moving faster, and this is because of very small mass of electron. Electron is very light in comparison to a proton. Okay, so you can solve this. You will find this ratio greater than 1. This proves that electron moves faster than proton. Okay, so this is question number 12. Let me share the next question now. Question number 13. This is assignment for you. Students, question number 13, you will do yourself. Read this question out. You all have the books, I suppose. So we will discuss it later on. You do this question in your assignment file. So let us see the next question. Wait. Let me share once again. Yes. Let us see this question. Number 14. A molecule in a gas container hits a horizontal wall with a speed 200 meter per second and angle 30° with the normal and rebounds with the same speed. Is momentum conserved in the collision? Is the collision elastic or inelastic? So there is a molecule in a gas container. It hits a horizontal wall with certain speed at angle 30° and it rebounds with the same speed. Okay, that way. Change in momentum will be 2mv cos theta, because each component, corresponding component of velocity will be v cos theta, and you can well imagine they will be in the same direction. So change in momentum will be 2mv cos theta, but we need not derive anything because you know that momentum remains conserved in all the types of collisions. Okay, so you can directly on the basis of that information you can predict that the collision will be elastic because momentum is conserved. Why it is elastic? Because gas molecules, collisions among gas molecules, they are considered to be elastic. They are assumed to be elastic, right? Let us come to question number 15. A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and the efficiency of the pump is 30%, how much electrical power is consumed by the pump? So let me note down the values first of all that are given to you and understand the question what is given. There is some electrical energy used up to operate the pump. Obviously, it is working with the help of electricity. So that input electrical power we have to find in this question. And it will lift the water. The pump is able to lift the water to certain height. Okay, it is lifting the water up to certain floor of that building that is given. Efficiency of the pump is also given 30%, and we know the formula of efficiency: output power over input power into 100. Input power we have to find, and how much is output power? That is the energy over time or work over time. Work has been done to change the height of water, to change the position of water. So in this case, work done will be mgh. So very simple question it is. Let me note down the values. 15th question this is. This is question number 15. All right. So what is given to us? Volume 30 meter cube of water. Time is 15 minutes. Time is 15 minutes. Height is 40 meter above the ground. take G 9.8, or if we don't have so much time, we can take 10 meter per second square, but we need to mention efficiency of the pump is 30%. Find input power or electrical power. Input power is electrical power in this case. So we have to find that. Okay. So let us do this. All of you apply this formula. Efficiency is output power. And what is output power in this case? Work. Work has been done to lift the power, lift the water through certain height. And input power is what? And power is there, so output work over time. Or you can first write simply, efficiency is output power over input power into 100. Then in the next step you can make it clear. Output power is output work over time into 100, and input power is what we have to find. Efficiency is given 30%. Efficiency is given out to be 30%. So let us put in various values and solve. 30 mgh xt, and this is 10 if we cancel 1 0 here on both sides. Mgh. Now how much is mass of water? That is also not given. Let us find mass using the formula volume into density of water. Volume is given 30, and we know that density of water in standard units, kg per meter cube, is 1000 kg per meter cube. So this will give us mass of water in kilograms. So let us put this value of mass here. 3 into 10 raised to power 4 kilogram. G is 9.8. Height is 40. Height is 40 meter. All right. So solve this and find x. Time also let us put. Time is 15 minutes. Convert it into seconds. 15 into 60. So find x now. Okay. You find x now, and you can express your final answer in kilowatt also if you want. You can express the final answer in kilowatt also. So all of you solve and find out the answer. Answer will be 43.5 watt, kilowatt. 43.5 kilowatt is the answer. All right, 43.5 kilowatt, that is your answer. Got it? Is the question clear to you? So have a look from the beginning. X is electrical power, input power that we wanted to find out. So I'm going to share next question with you. If you have any doubts in this question, you can tell me. All right. So question number 16 now. Question number 16 is, two identical ball bearings in contact with each other and resting on a frictionless table are hit head-on by another ball bearing of the same mass moving initially with a speed v. A situation is given. There are three balls. First ball is moving towards two other balls that are at rest. If the collision is elastic, which of the following is a possible result after the collision? On right hand side, three possibilities have been given, 1, 2 and 3. They are saying this may be possible that first ball comes to rest. V is 0 now. First ball comes to rest, and second and third balls, they move with half the velocity of initial ball, V by 2. Second possibility is first and second balls, they come to rest, and third ball starts moving with a velocity V only. And third possibility is that all the three balls, they move with 1/3 of velocity of first ball initially. So we have to find out in which case will be the feasibility, which will be the possible outcome. And you are already aware of Newton's cradle. Newton's cradle, in that case, when we make incident one ball, we hit one ball, only one ball comes out of the other end. So the possibility that is already you can make up in your mind, that is second. But we have to prove it mathematically. Let us see, momentum will be conserved in all the collisions, we know that. So we can't come to know whether collision is elastic or not from this. But kinetic energy, if it is conserved, as they have given that collision is elastic, if kinetic energy is conserved before and after, then that will be the possible outcome. So we have to find initial and final kinetic energy in all the three cases, and then we can predict. So let us find initial kinetic energy first. Let us find initial kinetic energy according to the situation given. Initial kinetic energy according to the situation given. We have first ball moving with velocity v, second and third balls, they are at rest. So initial kinetic energy of the system is half mv square. इनिशियल हमने निकाल ली, अब देखते हैं कि किस केस में इतनी ही एनर्जी आती है फाइनल. लेट अस टेक अप फर्स्ट केस. फर्स्ट केस में दिस इज गिवन that second and third balls, they move with half the velocity and the first ball comes to rest. First ball comes to rest. Let us find kinetic energy in this situation. So final kinetic energy in this situation will be, its energy is 0 plus half. What is the mass of both the balls together? 2m. Velocity is v by 2 square. Okay, so what we will get? We'll get 1 by 4 mv square. So in this case, the energy is not same as initial kinetic energy. So this can't be the possibility. ये possibility नहीं हो सकती. So we can rule this out. This possibility we rule out. Let us take up the second case. Second case, they have given that it is possible that first and second balls, they come to rest and only the third ball moves with a velocity v. Third ball moves with a velocity v. Let us find final kinetic energy in this situation. Both these balls will have zero kinetic energy. What is the kinetic energy of third ball alone? That is half mv square. So in this case, our energy, final kinetic energy is same as initial kinetic energy. So yes, kinetic energy is also conserved in second. Kinetic energy is also conserved in the second possibility. So this is our answer. Now you can check the third possibility also. Okay. This doesn't mean that in one case it is answer. You need not check the third option also. You must check. So I'm going to share the screen with you once again. So you can see and check the kinetic energy in the third situation also and tell me. So kinetic energy final will be in this case half, mass कितना है 3m of all the three balls together into v कितना है v by 3 whole square. V by 3 whole square. So let us calculate it, how much it will be in the third situation, in the third possibility. So in the third case, final kinetic energy is half, mass is 3m, velocity is v by 3 whole square. So this is 3 mv square over 18. Again, in this case, final kinetic energy is not equal to initial kinetic energy, half mv square. So we rule out third possibility also. So our answer is second one, that is Newton's cradle. On Monday, I'll be showing you what is a Newton cradle and how this mathematical situation is in analogy with the real practical situation, right? So any doubt in this question, students, you can come up. You can tell me if there is any doubt. And question number 17. Question number 17. So what is the situation given? There are two positions. Okay, this is bob A and this is bob B. It is going to hit this bob. This angle involved is 60 degree. Angle involved here is 30 degrees, sorry. And both the pendulum bobs, they are having same mass, m and m. They are asking that this mass is at rest, A mass is in motion. When it will strike, to what height bob A will rise after the collision? You know, it will come here and this bob will have to rise. So, but they are asking to what height A will rise. It will not rise at all. When bob A will strike here, since it is elastic collision and their masses are identical, they will exchange their velocities. We have done that derivation of elastic collision in one dimension. So when two identical bodies of same mass, okay, they collide elastically, they exchange their velocities. Initially bob B was at rest. After the collision, bob A will come to rest, bob B will rise. They are asking to what height bob A will rise, so it will not rise at all, and you will mention the concept along with it. So I hope this logic is clear to you. Bob A will come to rest because it will exchange its velocity with bob B, which was at rest initially. Okay, so what will be the answer? Bob A will come to rest after the collision because in an elastic collision between two equal masses, the velocities are always exchanged. They always exchange their velocities. It is clear? This concept is clear, students? All right. So have a look